down 5, what's the big cylinder? What's the little cylinder going to do? Go up 50. There we go, 50. It was there. Oh, love this story. Okay. So we'll do this in, because I like the cartoons, right? Hero, king of ancient Sicily. You understand that in Italy and in the Greeks, they had city-states. Okay? And so a city was a nation. And people lived around that, and they had allegiance to the king and everything like that. And at one point, I'm going to add to the cartoon. At one point, one of the other city-states gave their king a crown, right? And just like Keeping Up with the Joneses, that means everybody had a crown. And so Hero ordered a crown that was made, and basically he said to the jeweler, "I want you to make me a crown. Here's the gold. What's left over, you can keep as your payment, but basically you got to use all gold." And so the jeweler says, "Okay," and the jeweler makes this gorgeous crown. I mean, filigreed and carved and gorgeous and all those things. And everybody says, "Oh, it's beautiful, oh, it's great." And Hero feels really great about himself. He's got the best looking crown because he shows it off to all of his fellow kings in the other city-states, and his crown looks better than any of the other ones. But one of the other rulers goes, "I wonder if it's all gold." And Hero hears it. "What? My crown might not be solid gold? No, my jeweler wouldn't do that to me." What happens if he did? Well, what would happen if the jeweler didn't use all gold? Oh, off with his head. That's what would happen. Right? But how do you know? Density. But they could put the crown on a scale. That wasn't a problem. But how do they measure the density? It's got filigrees and it's got all kinds of stuff and it's beautiful. Right? So the king suspected. Now, why did he suspect? Because somebody else said, "Ha ha," started laughing at the king because they said it wasn't made of gold. Okay? Right? So he maybe mixed in some silver. What was his name? Try to cheat us. They made it funny. All right. So most of the really good city-states had their own personal scientists. Right? Actually, what did they call scientists back then? No, not usually. Begins with an al and ends with a chemist. An alchemist. Because what was the main job of the scientist? Right. Try to turn lead to gold. Can we turn lead to gold? Oh, yes, we can. It's extremely expensive. Way more than the gold is worth. But can we add protons and neutrons to the nucleus of lead and get it up to what gold is? Absolutely. It happens to be atomically unstable and it's going to have lots of radiation, but we can turn lead into gold. We can actually do it. It's a really dumb thing to do. Right? Okay, so he says to Archimedes, "You got to find out, is my crown all gold?" And so Archimedes has got to figure this out. He doesn't know. So he goes home and he thinks, and he thinks, and he thinks. And what does he do?
He takes a bath.
He takes a bath. But why does that make a difference, right? Archimedes is there thinking all day. He's brought up a big sweat and everything. So he goes to the servants, "Draw me a bath." I always think that's a funny phrase. Draw me a bath. So you get out a piece of paper and you draw. I mean, what good does that do? Right? So anyway, the servant draws the bath, right? And Archimedes, steps into the bath. And as he sits down, he watches the water level go up. And he stands up and the water level goes down. And he sits down and the water level goes up and he goes, "Cool." and so the servant pours in more hot water, and that wasn't what he meant. But anyway, right? So the water level keeps changing. And as the story goes here at the end, he figured it out. And he was so excited that he figured out how to do this that he ran from the bath all the way across the city to go tell the king. But of course, what was he wearing in the bath?
Nothing.
Nothing. So he ran naked across the whole city, shouting, "Vacuum cleaner!" No, he actually shouted "Eureka," which happens to be now the name of the vacuum cleaner. But Eureka means I found it. See, I never tell any story straight. Right? So, as he gets in, water goes up, does all of those things, and he realized that you can measure the amount of the volume of your object by how much water it displaces. All right. So now he's got to come up with, well, how do we do this for an experiment? How do we actually figure out? Because he's not allowed to just, I mean, shoot, what he could have done is taken the crown, beaten it flat into a brick, right? Gotten a pure gold, and compared the two bricks. If they were the same mass, then it was made of pure gold. But then you wouldn't have the crown anymore. Right? That's not helpful. So he had to come up with a way to do this. So he dreams up the experiment. He's going to find a gold bar of the same mass, same weight as the crown. And he's going to put it in, so it's important, filled to the brim, because when he puts the... Now, does he just drop the thing in? No, doesn't he very carefully lower it in? Because you only want the water to overflow that matches to the brick. If you drop it in, what happens? Which, of course, is what they show. So it's not exactly scientifically accurate, but then again, it's a story anyway. Right? So you remove the bar, and the water that's missing is equal to the volume of the bar. Uh-oh. So now you put the crown in. What are your three choices? Water goes up to the exact level it was at. Water doesn't rise as much. Or water overflows. So let's do the easy one. If the water goes to the exact level, what happens to the jeweler? He lives, keeps his head, because then it was gold. Right? Okay? If water goes to below, well, then he must have filled it with something that is more dense than gold. Not probable. What happens if water overflows?
Off with it.
Must have filled the crown with things less than the density of gold because it has more volume. And come on. Get pictures. Right? They put it in. They have that one. But, so, no spillage, gold bar. Spillage, not a gold bar. Right? Oh yeah, because which is heavier, 5 pounds of lead or 5 pounds of feathers?
Neither are the same.
They're the same, right? So we do that one. Gold is denser than silver. Silver would take up more space, more volume. Right. So now he puts the crown in. But see, Eureka was he was so excited because he actually figured out the experiment. Right? The king says, fix this, find out. And he had to be able to do an experiment that was not going to hurt the crown. Putting the crown in water is okay. So he figured it out and ran across the city naked, which is kind of funny.
Yes.
Right? He carried out the experiment, and unfortunately for the jeweler, the crown was not made of pure gold.
Oh.
And the story goes, he lost his head.
There's no picture.
But then again, Archimedes lost his head too. Later on. And Archimedes is famous for a whole bunch of things, right? Archimedes' principle and those things, and he was the one that supposedly burned up a bunch of ships in the harbor by focusing the sun's rays on them. I mean, there's all kinds of things that Archimedes did. Archimedes was a really smart guy. But there was one time where Archimedes was on the beach working on some formula, just, drawing in sand. And the king summoned Archimedes. And so he sent a soldier to go get Archimedes. And Archimedes was told by the soldier, you got to come and see the king wants you now. And Archimedes hadn't finished his formula yet. And so Archimedes didn't care. Archimedes' science was more important than some stupid roller, right? So Archimedes is still trying to work on figuring out whatever the formula was. Well, the soldier was so offended, he cut off Archimedes' head. Because he didn't come immediately to the king. And so the soldier comes and reports back to the king, he didn't come immediately, so I cut off his head. And the king looks at him, you idiot. And that soldier lost his head. So everybody loses their head in Syracuse. It's just a really dangerous place to be. All right, buoyancy and Archimedes' principle. There are a couple of things that then grow out of.
Do they know what formula he was trying to figure out?
Not that I know of. I mean, it's a story on why he lost his head, but I'm pretty sure that's the accepted story on why he died.
Oh, okay.
But what he was working on, I don't know. He could have been drawing birds.
Could have been curing cancer.
Yeah. that I don't think they really understood cancer at that
Thanks a
point.
lot, soldier.
Yeah. Okay.
So many deaths.
Buoyant force. If you go to the Great Salt Lake and you walk into the Great Salt Lake and you stay vertical, okay? You can't sink to more than about the middle of your chest. All right? When you go to a swimming pool, how far do you sink? Your chin. Me, I gotta have my head back and just barely, and it depends whether I breathed in or breathed out. Because if I breathe out, down. All right? Because we are very close to the density of water. Our bodies are. All right? Most of us is more dense than water. Why is it then that we float? Because we have a lung cavity. That lung cavity has a very, very low density, which gets to lower our general density to be able to do that. But the buoyant force, when you have something, an object, you put it inside the fluid, it appears to float. It has it depends whether it floats or not. Oh, I'm sorry, I'll call you back. All right. Hot air balloons. Why do they float? Why do they float, though? They are being buoyed up. They have a buoyant force. It means the amount of weight of the fluid they are displacing. Now, in a hot air balloon, what fluid is being displaced? Air. But doesn't air have a weight to it? Means why we have pressure on top of the table that was worth 10 cars. Okay? There's something like, what, 1.38 kilograms per meter cubed? Or no, 0.138. I don't remember what the density of air is, but it's pretty small. All right? But hot air, isn't that less dense than the cold air around it? And so if I can displace more weight than I am, I float. So can a solid steel ball float? So how would you make it float? Yeah, mercury. If I put a solid steel ball in mercury, it floats. Right? Okay. Aren't most big ships made out of steel? Why do they float? Because they're mostly air. The volume of the ship is mostly air. So the density of the ship compared to the density of water is way less than water, and it floats. Those are the things that we're looking at. All right? So, force buoyant. It's equal to the weight of the fluid displaced. On the bottom, that's the mass of the fluid times g. mg is weight. And mass, remember we did density? Density is mass over volume. So mass is density times volume. So the weight is the density of the fluid times the volume of the fluid times gravity. It's still the weight of the fluid displaced. That will be the buoyant force. If the buoyant force is greater than the object's weight, it'll float. Until it just displaces enough to be equal. Okay? So, an aluminum object that's 27 kilograms, a density of black, attached to a string and immersed in a tank of water. All right, what's the volume? How do we use those two numbers to get volume?
Density
Times mass. Volume
Right.
plus-
I'm going to take 27 kilograms divided by 2.73 kilograms per meter cubed, and I get meters cubed. Right? You make the units work. Okay? So that's the first thing we get. My volume within there. So 0.01 meters cubed. Determine the tension in the string when it's completely immersed.